So far we've done the power rule. We did the figuring the first derivative by the long method, and then we did the power rule. That's what I call basically the shortcut. The power rule was if I gave you y equals like 5x to the third, the power rule finding the first derivative was just take that exponent times the number in front and then depress the exponent by 1. That was the power rule. Then we did the product rule. Okay, and the product rule, remember, was you have to look for two quantities that are multiplied together. If they had something like this, something like that. Product rule says leave the first quantity the same times the derivative of the second, which would be 15x squared. The derivative of the constant is just 0, plus leave the second quantity the same times the derivative of the first, which would be what? 6x. And then you would have to multiply this out and combine like terms. And remember, you can check almost all of the problems figuring derivatives. You can do put the original in y sub 1. In y sub 2, you'd want to do the numerical derivative of y sub 1 comma x, and then put your answer in y sub 3. And these two, the calculator's derivative and your derivative, autograph the same thing. So we did the power rule, product rule, then we did quotient rule. In the quotient rule, they're just going to look at, let's do something like this. Say I give you something like this. Quotient rule, what do you have to start with? The denominator. You start with the denominator times the derivative of the numerator, which in this case would be, what would it be? Negative 12x, and then minus, then leave the numerator the same, times the derivative of the denominator, which would be what? 24x squared plus 9. And then it's all over that denominator squared. And usually they don't square that out. If you do square that out, remember it's a trinomial square on the bottom. Okay? And you would have to simplify all of that out. Okay, so that's what we've done so far. We've done the first derivative by the long method. We've done the power rule. That would be this one. We've done the product rule. That would be this one. And then we've done the quotient rule. The one that I said last week that we have not done is a quantity to a power. And that's what we're going to do today. And that's what's called the chain rule. Okay? So I want to go through an example. If I said find y prime, okay, if f of x equals the quantity 2x squared minus 4x plus 1 to the 60th power. Oh, the long method would be to take that quantity times itself 60 times, which would be awful. That would be terrible. Okay, so there's another rule, shortcut, the chain rule. If it's just a polynomial to a power, okay, f prime of x equals, and I do want you to get used to writing down the original is f of x, and then you're finding either say it f prime or y prime, okay, equals. Okay, everybody watch up here for a minute. Here's the shortcut. You take this exponent times the number in front out here. So 60 times 1 would just be 60. The part inside the parentheses stays the same. Depress this exponent by 1. Okay, now here's the extra part. It's times then the derivative of what's inside. So what's the derivative inside? minus 4. And then this has an exponent on it. These two quantities don't. So I can simplify. I can multiply out the 60 times this, and they will usually do that. So f prime of x then would be 240x minus 240 times the quantity 2x squared minus 4x plus 1 to the 59. Now, there's an error in that answer. What did I do wrong? Yep, I need to parentheses around this. If you don't have parentheses around that, it's just the 240 times everything. No, it's that quantity. Okay, now, let me say it again. When you figure the derivative of a quantity to a power, okay, you take this exponent times the number in front, which in this case is understood to be a 1. The part inside the parentheses stays the same. You depress this exponent by 1, and then it's times the derivative of what's ever inside. Okay? Now, you need, every time you work a chain rule, you need to be saying that in your mind, in your brain, so that you get used to it. Okay? One more time. You take this exponent times the number in front. The part inside the parentheses stays the same. You depress this exponent by 1, and then it's times the derivative of what's inside. And then you will usually simplify this times this and make sure that you have parentheses around that. Okay? Are they going to simplify this? No. No. Just leave it quantity to the 59th power. Okay? Okay, now that's one way to work that problem. Then the author is going to go through another method. Okay? And I want to show you both because you may end up with, in a Calc 2 class where they do it a little bit differently. Okay? Same problem. Okay? Let's say they let, let's say our f of x is still 2x squared minus 4x plus 1 to the 60th power. Okay? They are going to let u equal this quantity inside. Okay? Let u equal 2x squared minus 4x plus 1. If u equals that, then I can rewrite this problem as y. I could use f of x or y. Y equals u to the 60th power. Okay? Then they're going to rewrite, and it's basically what I've said in words. They're going to write it. You need to figure the derivative. Instead of saying f prime of x or y prime, they're going to write it the derivative of y with respect to x. You read that, the derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. When it says with respect to x, that means it's got an x variable in there. They might write it like that. Okay, the same thing can be written like this. The derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. Okay? Now, here's what it looks like working the same problem, except that you're letting u equal a quantity. Okay, so they would say the derivative equals, you would, well, let's just do it over here. The derivative of y with respect to x equals, okay, what's the derivative of u? So you have to say, what's the derivative of this? You take power rule, just take that 60 times the number in front, which would be 60. U stays the same. Depress that exponent by 1, so that'd be 59. Times. Then this says, you take the derivative of u with respect to x. So you have to go to this. What's the derivative of this? 4x minus 4. Okay? and then you substitute back in. If you started with an x, you've got an end with an x. So then you would substitute back in 60, and the u was this whole quantity, so we're going to sub that back in. 2x squared minus 4x plus 1, and 4x minus 4. And then you would go ahead and combine the 60 times the 4x, so it would be 240x minus 240. Oops, I left off the 59. And then 2x squared minus 4x plus 1. Okay? That's a little bit different way to write it. But the reason I do that is down the road when we start doing some things backwards, you actually you need to know this method too. Okay? Okay? Okay, so let's look at this a minute. On this, this just says take the derivative of y with respect to u. So you look at your formula with the y and the u and say find the derivative of this. Okay, and then this part just says take the derivative of u with respect to x. So you look at this part of the problem and then sub back in. Okay. Okay, let's do another one. Another problem. Draw a little separator here. This will be that was example 1. Let's do example 2. Say they ask you to find y prime if y equals 1 divided by the quantity 2x to the 5th minus 7, and that quantity is to the 3rd power. What tells you that you have to use the chain rule is that you've got a quantity to a power. Okay? But if I look at this problem the way it is right now, I'm stuck in quotient rule because I've got a division, and chain rule because I've got a quantity. But I can make this easier if I rewrite the problem first. A lot of these you can do it easier if you rewrite the problem first. So how can I move that whole quantity up? Yep, make it to a negative power. So it'd be 2x to the 5th minus 7, and that's to the negative 3 power. Okay? I'm going to write that again. I didn't write that right there. To the negative 3 power. Okay? Now, if I'm doing chain rule, now do your y prime equals. I usually don't write it out, all of that out the other way, but I'll use it again here in a trig problem in a minute. So what I do is I take this exponent times the number in front. Okay, and so that's just going to be negative 3. The quantity inside stays the same. Okay, now don't miss this. Depress that exponent by 1 to the negative 4 times the derivative of what's inside. So you have to say, okay, now what's the derivative of this? 10x to the 4th, right? Okay, and then the only part they will simplify this times this. Okay, because that other is to a power. So y prime equals, so it'd be negative 30x to the 4th. And if they said no negative exponents, then we would move that quantity down 2x to the 5th minus 7 and make it to the positive 4 power. Okay? Any questions on that one? Chain rule. And you got to get used to saying that. Take that exponent times the number in front. That quantity inside stays the same. Depress that exponent by 1 and then times the derivative of what's inside. Okay? If you have to, go back and listen to it on iTunes U so you get used to saying that. Okay? Okay. Another example. Find the first derivative if y equals the sine of the angle, and the angle is x to the 3rd minus 3x. Okay? Now, on your card, you've got formulas for like figuring the derivative of sine of x if the angle is x. You don't have anything if the angle is something other than x. So, here's the first thing they're going to do. They're going to let u equal that angle. Let u equal x cubed minus 3x. Okay? So now we can write this as the sine of u. Okay? When you figure the derivative, the y prime, okay, it's like the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. Now, you don't have to write it that way each time, but you've got to be able to work the problem. So, if I figure y prime, first you would look at your card and say, what's the derivative of sine? Cosine. So, it's cosine. The angle stays the same, cosine of u, times, now this part says take the derivative of u with respect to x. So you got to go up to this and say, what's the derivative of that? Minus 3, and that's in parentheses. Okay? Okay, now, this is an angle. This is going to be a coefficient. So you're going to move this out front. Okay, so y prime equals 3x squared minus 3. That needs to be in parentheses. Okay, times the cosine. Now I could say cosine of u, but what's u? Sub that in. If you start with an x, you've got to end with an x. So our y prime final answer is the quantity 3x squared minus 3 times the cosine of the angle x cubed minus 3x. Okay? So when you do this, you say let u equal whatever that quantity is. And then figure on your card what's the derivative of sine. It's cosine. The angle stays the same. Then it's times the derivative of the angle. And then move that coefficient out front. Okay? Everybody okay on that one? Okay, another example. Is that enough time? Okay. Okay, say I ask you to find, and they can write it, remember, we can write it like this, find the derivative of y with respect to x if y equals. Okay, this is a numerator and a denominator and a quantity. Up in the numerator, t cubed minus 2t plus 1, and it's all over t to the 4th plus 3, and that whole thing is to the 13th power. Okay, y prime. You have two things going on here. You got a quotient and a quantity to a power. The chain rule takes precedent. So you're going to take this exponent times this number in front, which I understood to be a 1. So it's going to be 13. The part inside the parentheses is going to stay the same. So it's just going to be, keep that the same. Depress this exponent by 1, and then it's times, now it's times the derivative of what's inside. Okay, now you got to look at what's inside and say the derivative of what's inside is a quotient. Okay, I would rewrite that as something else. Say g of t equals okay, and then find g prime of t. Okay, quotient rule says start with the denominator times the derivative of the numerator, which would be what? (3t squared minus 2), and then minus Leave the numerator the same. I'm running out of room. I'm going to bring this down. Whoops, bring it down. Okay, so we have we left the denominator the same times the derivative of the numerator minus, leave the numerator the same, times the derivative of the denominator, which would be 4t to the third, and it's all over that denominator squared. T to the fourth plus 3 quantity squared. Then you would simplify all that. When you simplify all that, oh, wait a minute, I need to copy it. And that goes back up here. Except I need to erase part of it. The advantage of a tablet. Okay. Okay. So let's go through it again. You take that exponent times the number in front. The part inside stays the same. Depress that exponent by 1. Then it's times the derivative of what's inside, which happens to be a quotient rule. Okay, and you would have to, we're not going to simplify it all out in the notes. You would have to simplify all of that. Okay, combine like terms, all of that. And remember, this minus sign affects all of this. Okay, so you may want to do like another set of parentheses or brackets right here. Okay, and then you simplify all that out. Okay, you could simplify this times this. Oh no, you don't want to do that. You don't want to do that because you've got an exponent on the outside. Okay? So all you could really do is simplify out all this and take it times 13. Okay? Gets kind of ugly. Okay? Any questions on that one? Okay, another example. Number 5. Say y equals the cosine of 3x. Okay, now, on your card you've got a formula for cosine of just x, but this is cosine of a quantity. Okay, so on your card, look, what is the derivative of cosine? Negative sign. So the negative sign and the angle stays the same. Negative sign of 3x, then it's times, what's the derivative of the angle? What's the derivative of the part inside? Just 3. And then they will simplify this with the negative 1 in front. So y prime would equal a negative 3 sine of the angle 3x. Okay. Now, what if they change this? What if I say y equals the cosine? They might write it like this in the book. Okay, but you don't want to write it like that. You want to write it so it looks like a chain rule. Okay, so rewrite the problem first. Rewrite it so it's cosine of 3x. It's kind of like rewriting it so you can put it in on your calculator. Okay, you know, the calculator won't let you put in that squared. You got to put it on the outside like that. Okay, now it's the chain rule. So on these, I do want you to make sure you have y equals and y equals. Now you're going to do y prime. Okay, now you do the chain rule. Okay, so take this exponent times the number in front. Okay, so it's just 2. The part inside the parentheses stays the same. Depress this exponent by 1, so it's just to the first, times the derivative of what's inside. So now it's times the derivative of this. What's the derivative of that? That whole thing, right? If I had not worked out this first part, I would have to say, okay, Depress the exponent by 1. Now it's times the derivative of what's inside. So I'd say, what's the derivative of cosine? Negative sine. The angle stays the same. And then it's times the derivative of the angle. Okay, which is the same as what we got over here. I just haven't rewritten it yet. Okay, so now you got to take this times a negative 1 times 3. Put that out front. So y prime equals negative 6 cosine of the angle 3x times the sine of 3x. Okay, and that's the final answer. Okay, let's try another one. Is that enough time? What if they change it to y equals, to problem 7? What if they change it to y equals cosine of 3x, and this time have the exponent on the inside? Y equals cosine of 3x squared. This one, the exponent was on the outside. Makes a difference, okay, in your answer. Okay, so y prime equals. Okay, so you look on your card, what's the derivative of cosine? Negative sine. The angle stays the same, 3x squared, times the derivative of the angle. So what's the derivative? 6x. And then that should have a y prime on it. Make sure that has a y prime on it. So y prime equals a negative 6 sine of the angle 3x squared. Totally different answer than this one up here. So where those exponents appear makes a difference. Okay, okay, last example. So I give you y equals the quantity x cubed plus the sine of x, and I'm going to put that angle as a bracket. And that quantity is to the 6th power. Okay, y prime equals. Chain rule, because anytime you got a quantity to a power, you can use the chain rule. So you take this exponent times the number in front. The part inside stays the same. Depress that exponent by 1. And then it's times the derivative. It's times the derivative of what's inside. So you have to say, what's the derivative of this? What's the derivative of x cubed? 3x squared. And then plus, what's the derivative of sine? Cosine. So it'd be cosine, and it's actually just cosine of x. Okay? And it's that quantity. Okay? So y prime equals. They will simplify, and they're going to multiply this times this. Okay? You could distribute that and say it's 18x squared plus 6 cosine x. That whole quantity, you got to have parentheses, brackets, something around it. And then times x to the 3rd plus sine x. And that whole thing is to the 5th. The most common error, and I do it too, the most common error is people forget to write down that exponent. Okay? Just have to remember to do that. Okay, now, on your card, go to page 226. On your formula card, okay, in that blue box, $226 in the blue box. Now, the very first one is the power rule. When you say take the derivative of u to the n power with respect to x, you take that n times the number in front and depress the exponent by 1. And then the difference is This u is standing for a quantity. Okay? Then it's times the derivative of u with respect to x. That is basically what we did all the way back up in the first one right here. When we did this, this is our u, okay? And this is our n. You take that exponent times the number in front, the u stays the same, you depress it by 1. Then it's times, this is the derivative of u with respect to x. Okay? So that's what that very first one is. When you're looking at that u represents a quantity. Okay? On the next one, when you read that, the derivative of sine of u with respect to x, derivative of sine is cosine. That angle stays the same, but that u, the angle, represents a quantity. Then it's times the derivative of the angle with respect to x. Okay? So when you see that u, that might be like 5x squared minus 10x, something like that. That u represents a quantity. Okay, so when you say, oh, I left out one. No, that one's right. Derivative of cosine of u with respect to x, it's a negative sine. The u stays the same. Then it's times the derivative, and I usually read it as an angle when you're doing a trig function. Then it's times the derivative of the angle with respect to x. Okay. And then the derivative of tangent of u with respect to x. It's secant squared u and then times the derivative of the angle with respect to x. Okay. And then the reciprocal, remember, well, they don't have them in the right order. I'm going to change the order up a minute. Sine, what's the reciprocal of sine? Cosecant. So let's switch that up again. Derivative of cosecant of u with respect to x equals negative cosecant of u times cotangent of u and then times the derivative of the angle with respect to x. And the derivative, or the reciprocal of cosine, is secant, so let's put it next. The derivative of secant of u with respect to x equals secant of u times tangent of u times the derivative of u, derivative of the angle with respect to x. Okay, and the derivative, or reciprocal of tangent is cotangent. So the derivative of cotangent of u with respect to x is a negative cosecant squared u and then times the derivative of the angle. Okay. So this just says when you're doing, like, if I did a cosecant graph, if I did a cosecant with a angle that was a quantity, it's just negative cosecant of that quantity, cotangent of that quantity, and then you got to take the derivative of that angle. Okay, so you have 6 formulas on your card where the angle is just x, and now you have 6 formulas on your card where the angle is a quantity. Okay. And that's the difference between those. And on these, you're using the chain. This is the chain rule with trig functions. Okay, when you're using this part of the card. Okay. Okay. I purposely